All right. Yippee skippy. Cooking with gas, except it's illegal now. You have to cook with electronic or with electric, right? New housing is getting all electric. They're not putting in gas because apparently there's some sort of benzene gets into the air. All right, log into the Jeremy box and we're going to do some assembler stuff to start with. And we will start with a really simple thing. I'm going to start with a module that we'll type in, and I will try it from, see, which is easier for you to see, this or the Jeremy Lab notebook?
I think for me, the Jeremy Lab.
Okay, because I can make this bigger, but then I get into other problems. Okay, let's go to the Jeremy Lab here, and I can change it from light to dark without jumping through too many hoops. There we go. All right, so what we'll be doing today is we'll be typing in some code. So you can use either the editor that's built in to the Jeremy Lab that'll make your life a lot easier, or you can follow along with me using VI. And Nano, if you've played with it, you'll find Nano's not out there. It's out there. I just renamed it. And you have to bribe me with coffee to find out what the new name is if you really want it. Okay. All right. So let's make a directory here. mkdir, and we're going to call it homework WIP for work in progress. And if I go too fast, slow me down. To start with, I want to introduce you to a new command that is on this box now. It's called clang format. And it doesn't do anything except format your source code. Okay. It's part of the LVVM compiler suite that does all kinds of magic. And I'm going to introduce this later as we move on into our little room. Is it sometimes you will get code that is just a mess and you can't even read it. So you need to format it before you can do anything with it. So the note to self. So the first thing we're going to type in is this thing called demo C. We're going to call it demo in.c. Okay. And this is a very simple piece of code. Demo n.c. And this would be the compile line. We're not going to do anything with the debugger on this code yet. Okay, we're just going to learn how to use an input statement from the user and print it. Okay, that's what this exercise is about. Okay, and it will be demo n.c -o, we'll call it demo 1. And then I noticed something today. Notice that when I type this in, not on this box, but on the formatter, I'm using a different, you can choose different fonts when you display things in the terminal. And I've been using a font that is used, the same font that's used for people that are visually impaired. And it comes from Intel, and it makes their squirrely brackets really squirrely. So you don't confuse them with anything else. They go, wow, I kind of like this. So I'm using that font, and you can download it from Intel and install it on your machine in choice. Okay. But that's the one I've been using lately. This is, well, I should say Integer. Now, this is probably something you haven't seen. Because in C++ you use C in and C out, and it's a lot cleaner. This is C. This is the basically C is the assembler of choice in today's real world. When you need to write a device driver, you're going to write in C. You might use assembler for some optimizations for a little teeny tiny part, but generally you'll be writing in C. Okay. There's a nice long story here. Now, if I can type and talk, we'll see how well this works. IBM rewrote all their TCP/IP stack in, at the time, C++. And their networking slowed almost 60 to 80%. Their customer base just screamed bloody murder. So they rolled it all back and wrote it again with highly optimized C, and they got even better performance out of it. So it goes to show that jumping on the latest bandwagon may not be the best choice. You may get rich by using bleeding edge, but you can also lose your job. And I put that at the end of my code. So this is the code. Can y'all see it?
Yeah.
Okay. You can snap a picture, and I'll put this up on the website. What this is doing, this is a C version of how you get something from the user. And it's using this scanf. And it says %D as in decimal, give me a decimal number. And the ampersand number is saying, go to the location where the number is and get the contents and put it there. So when I display it, I actually get my information. In other words, using a pointer, go to the pointer where that is and bring back the value. Okay, that's kind of what it's doing. So let's see how this works. So GCC, demo in, out, demo one, or whatever you want to call it. And we can give it a standard. I think the default is C99. And for us, it doesn't matter if it's C11 or C99. We're not doing anything that tricky. Demo one, and we say 45. You entered 45. Okay. Now let's take a few minutes and get this to work. Because where this is evolving is we are going to take this code and turn it into the argv argc. What I'm doing is giving you code that's similar to what you need to get done for your labs, but is not the exact same. So you'll need to extrapolate what you're learning here and how to apply it there, which I'm hoping is a good learning exercise and not too terribly frustrating. I know how some of this can go. It can be beyond frustrating. Okay. And two, if you run into problems with any of the servers, ping me on Slack. It'll say, hey, down. You know, because I'm usually on Slack somewhere. Okay. I have it up at home here, various computers around. Let's see. Let's open that. Yes, sir.
If we get permission denied to run it, is there something that we should change? If it says permission denied when we try to run it, is there something that we should change?
What directory are you in? Usually that means you're in some sort of a system directory that you don't have permission to write it. So type in TWT. And type in, see, did VI demo, see, how many are getting that? Type in UMass. But when you type in touch demo and let's see. Yeah. Do it LS minus L. Now do it via. Then when you compile that, you got a permission tonight. So you save it like this. Yeah, you need // demo one. No, just demo one. Yeah, type in demo one. / demo one. No, see. There.
Oh, there we go.
Yeah, the permit, yeah, okay, I understand. Okay, let me explain what's happening here. Is that you edit your source code. And we did this compile line. And then I breezed over it really quick. Is that if you try to run this, you will get permission denied. Because you can't run object code that hasn't been compiled. Now it'll work because that's the -O, the output of our compile is demo one.
Oh,
good.
Yeah.
That's fine. Use it. Probably be a little easier than watching the video. We have success. We're getting there. Yeah. So in our computer science club, you folks are really gonna know the difference between compiled and interpreted languages. Right? You're really getting the feel for this. We are going to meet again Thursday in this room. And if you made it last Thursday, Jonathan Leal was talking and he mentioned to me afterwards, every time I looked in the camera and I saw my face on the screen, I lost my train of thought.
So this Thursday is gonna be an unofficial meeting, because we don't have everybody.
Everybody's not trained yet? Or,
That might be it. I think a couple of the people in leadership aren't making it or they can't make it to that time. So it's gonna be unofficial. I'm gonna be there. But
okay, all right, so yeah, we just need to create a better communication. I haven't finished the training yet either.
yeah, so that we just decided that yesterday.
Yeah, well, that's fine. The training, you have to go through it every year. There's a video, but if you're ever in clubs, folks, download the quiz first and then watch the video and then fill out the quiz as you go through the video and then go back to the quiz and put in the answers. Because the questions they're putting on the quiz are obtuse. It's like they want to make sure you watched the video. Like, what law says you can do this? Like, I don't remember.
I like this website called Assembly AI. You can just throw a video in there and it transcribes it all. And does
Oh, that's the way to do it.
analysis on the-
That's the way to do it. Get a transcript of
Yeah,
it.
yeah, and then I can tell what.
Yeah. Send your answers to the other club leaders. Yeah, I won't say anything. All right. So we got it. So we've created a simple scanf statement, which this is how we get user information from the user and then display it. That's all we're doing here. Okay. Now, our next piece of code we're going to write is we will be using argv argc, aka C, using GCC to see how this argv argc stuff works. Okay, you get it working? No? Yes? Let's get it working. Let's get some successes here. Everybody got it working over here? Almost? Oh,
So right since last change. Oh, next week. So I jumped it over.
yeah, learning PI is fun.
Oh, I think I just have to extra lines. I don't know if it's saved. Hey, we're all learning here.
Hey, that's the way it works. We're all in this together. No pressure. I'm just standing over you watching you type. And then it says there's some errors in your code. So it'll be yeah, demo. Yeah, your source code. And then hit E for edit. And let's take a look at this. Oh, semicolons are kind of important. You see, it really squawks. Balanced quotes. Saying Ray / in program on line 10. So hit up arrow to go anyway. To my line 10. Down here, that is on line 14. Oh, you need a percent of T slash in. It's all right. There, we go. Now try it.
Like 5 followers.
Isn't there? We're on now on line 11, return 0. It says expected semicolon before swirly bracket. Okay, so let's go look at that. Return. Really hard to see, but you got a quote and a quote and a quote, so that remove that little quote. Nobody can type, somebody's watching over your shoulder, especially you're trying to learn VI. Mission .slide demo. Fair number. Success! Yay! It feels good to have it work. And yeah, these little syntax things in VI, there is when you move your cursor over to this and you use shift %, shifted 5, it will find the balanced quote or the balanced open close paren. So if you put it on a paren, it'll do the same thing. So it's just shift 5 and it just finds the balance. It finds where it thinks the other one is. And it's a quick way to check to make sure you have all the open and closed ones. But the more sophisticated editors do all that for you anyway. Okay. Now that we have that working, let me show you the CLang format. If you type in CLang format demo in C, it doesn't do anything. It just displays it to the screen. Okay. You can edit, you can do the in place. You can actually format your code in place and it takes your original code and formats it and writes it back out. If you don't mind dancing on the edge of brilliance, that's fine. I generally go to an output file and say, let's see, look at this, check 1 or something. And then I will look at it and see how it looks. And you'll notice what it did is it took out some of my indents. It formatted it according to whatever the format is that CLang does. So there's a consistent format. There is also, when you work at Google and Facebook, they have a style guide to which you will write your code. And you just look up your style guides for Python, or you look up your style guides for the language you're working in, and they tell you what their style is. And they give you generally all the add-ins to your tool chain of choice, so you don't have to work at it extra hard. Like if you use VI, they give you a VI plugin that formats all the code the Google way. Okay.
You can even see what it did. It do an output file and then you diff and then your first file and then your second file. It'll show you all the changes.
Right. That's where I was going next. If you this diff, we take the original and then the output, and it shows you what changes. Okay. So you can see that these got pushed in compared, that's the differences. And diff will pick up space differences. It's a pretty sensitive tool. Okay. Comes in really handy. Okay. So it looks like it works fine. So I can say move check 1 to demo in. And now I have just my same files in there, but now demo one is all free. Okay, so the CLang formats your code. That's all it really does. Okay. Now, ready for our next adventure in typing? Yes. Now, this one is going to be called VI C underscore args dot C. Okay. Whoops. Insert. And the compile line, again, is going to be pretty simple. And we'll just call it check args. Really simple. Now, as we type in this code, and line R count D. So I'm prepending this with a carriage return just so it makes it display a little bit nicer. Since I know most of you are Windows users, I'm using this exe name. This is the executable name. And it says %S, I mean string. I'll have to explain all these quirks here once we get it working. This also shows up in the Linux class for Bash. This also shows up in your PowerShell. This also shows up in any shells that you use: Z shell, corn shell, C shell, the extended C shell, on and on the list goes. Okay. And now we write a for loop in the C way. This is some obtuse code. But that's okay. I'll explain it. It makes perfect sense once you know what it's doing. And then at the very end here, we put in a print F. Just so we can get our prompt back to the right place. Here, that shouldn't be cheer, that should be car. And it should be a knit. Knit main, argc, car, argv. Declaring an I for integer. That's going to be our counter for our loop. And then command line argument count, which will be argc. And then what the executable name is, zero indexed array, argv here. Okay. And then argv1 is the total count of arguments. And then for our loop, we set up an argc, and it just sits there. As long as there's something in the argc, it's going to increment. And when it runs out of stuff in this variable, it says, okay, exit. This line prints out the argument where it is, its number, and then the value, which is a string. Now, if you put in, I'll show you what this means. I'll show you what that means when we get there. Okay. All right. This is, let's put a couple spaces in this. So it makes it's a little cleaner. I think that'll be okay. That should be okay. I'll cat it one more time. So everybody knows what we got here, so I'm going to use that. Wonder if that'll work. What I was afraid of. I haven't learned how to use that editor yet. So it is. And we'll call it check args. Really simple. Now when I run it all by itself, that's what I get. It says the total number of command line arguments is 1. Well, that's the name of the program. That counts. Okay. And then it says, what's the exe name? All right, it's check args. And the number of arguments I have after that is null. So now I can run it. And it tells you argument number 1 is 1, 2 is 2, 3 is 3. Okay. I can also go backwards here. 5, 4, 3, 2, 2, 2, 1, 1, 1, 1. And it will show you what these are. Remember, it said the argument count is a just $D or $D decimal. And then notice this was %S. So even though it's a number, it's a string, which allows me to do this. So I can put both words and numbers on the command line. and display them. But we have done nothing fancy. Do we have any sort of air condition in here? No. So let's explore. Let's see what happens when we use some funny looking characters. How about let's go 2, 3, 4, and a pound sign. Didn't put the pound sign in. How about if I put a 9 after that? Nope. What if I use 2 pound signs or 3 pound signs? It just stops at the pound sign. That must mean something somewhere. What about an asterisk? What? What did what? What did the asterisks do? Echo star.
Oh, it listed all the things.
Bingo. So if you don't have, if there's a machine you're on and you don't have a LS command, echo star will do the same thing. Tells you everything that's in the directory. These characters are special in all of the shells, PowerShell, and even old command line as well. And let's try this one. Let's try 1, 2, 3. Question mark. Well, it took the question mark. How about the tilde? What's the tilde, folks?
Your home folder.
Pardon?
Your home folder.
Home folder. Remember when you type in your Jeremy fully qualified domain name to get to your website, http jmkll.org/tilde login name? What's tilde? It's your home directory. So you can type in cd tilde, and where are you? Your home directory. Tilde is a shortcut for home. That has been around as long as I've been pushing Linux bits around, okay? So what other special characters can you find that do something weird with our, so what about that one? Ooh. Anybody know what that's for? In the world of Linux and Mac, this says take your code and run it in the background and then go off and do something else for the user. And when it's done, return. So all these special characters have a meaning. So generally, when you're collecting data from the user, you have to vet it. In other words, you need to check it. Otherwise, it's going to give you a major headache. Okay. So let's go ahead and send this around. 10.3, right? Yeah. I think this pen works. If not, scribble away. All right. So we've now done some argv and argc with this. So eventually, you're going to take your main, your foo-h, and your foo-c, and you'll put in the scan. It'll be a kind of a 2-step process. Because right now everything's hard-coded. You have a number and you pass it and it comes back and it adds 8 to it, right? That's all it does. or 5. I think it's 5. Or is it 8?
It was
8.
the last time we did it.
Okay. Okay. So what you'll be doing is modifying your code to pass a number back and adding 8 to it and bringing it back. That is going to bring home the idea of how does a function work and how do I pass a variable to a function name and return back that function value. That's programming 101, any programming language that uses functions. There's a few out there that don't. But you probably won't see them in unless you've got some very weird, obscure thing to do. Okay. All right. So there's those. And now I want to move on to. I want to do that one. I will jump on over to that. Let me do this. This over here. I think what I want to do is show you a few other little things with our compiler line and then jump into this right here. So we've been compiling with a very simple playing around with this. Right. Playing with lots of check args. Try this. What did it add for us? Well, we got this I and we got this S. When we use the dash save temps, the GCC and G++ compilers are 2 paths. They go through it once and then they create an intermediary and they go through it again. Okay. And when you say save temps, it's actually saving these intermediary steps so you can see what the compile process is. Because as a computer science major, you will have to write a compiler and you'll probably use the Dragon book and learn how to parse tokens to do certain things. And the tokens is how you break apart your C source code into things that you can turn into assembler. You know, that doesn't sound too hard. Well, until you try it, it's a lot more convoluted than you think. But once you, what I'm giving you here in this class is a good foundation to be able to, oh yeah, I remember that. I remember that. I don't remember how to do it, but I remember how the pieces fit. That's going to save you a lot of headache. Okay. So now if I just look at this cat, I'll bring it up in the editor. Check args -c args.I. So this is the I for intermediary. And I don't remember what all these numbers mean. But look at all that stuff that gets included when you type in stdio.h. That's the only thing we included, right? Well, it included all of the stuff that's unique to my architecture as well. So if you were doing this on MIPS, it would look differently. Okay. It's a lot of stuff. Okay. $700 lines from our file code. There's the actual code. Well, that's the I. Look at the S. This is the assembler, sort of. Okay. Is this Intel format or gas?
Yes.
This is gas. Because we didn't tell it to do the Intel on the command line. And you can tell because it gives you all these funny looking percent signs all over the place. Okay. And we've learned the hard way. You can't just take this and compile it with AS. You can if you use GCC, because GCC will pick up where that left off, and you can link it using GCC. Okay. And then down here, oh, those are the pointers. I don't think it puts it in here yet. No, not yet. Okay. So those are the save temps. Now, if you were to create a make file to work on these files and then say make clean, and it would delete the .o, .s, and .i after your save temps. Okay. Note to self, might want to remember that. Okay. That'll be part of the thing. All right.
So how did you generate those again? The IS?
Oh, good question. I showed it to you once. You didn't get it? You don't have photographic memory? Oh my. No, I'm guilty of this. Yeah. Save temps will save all the temporary stuff that the compiler's doing. And I don't know if you heard Jonathan when he was in talking to the computer science club. How many were actually here for that? There's 2 of you, maybe. He said Python and the debugger PDB really helped him dig down and find some of those problems. Because what does he do? He's a site reliability engineer for 15,000 computers around the globe. And he writes a lot of Python code using Salt Stack and Ansible and Puppet and Chef, and uses Jenkins and Test Kitchen, and it's all Python based. So when you add these layers of software and you're using this library and that library and you go through it and it breaks, what's your tool of choice? The debugger. And Python has a PDB that works very similar to the GDB that we went through. I showed you that. Okay. So he's probably making 3 times what I'm making. Okay. Literally. So if somebody like that says Python and the Perl debugger is what he's using, and if you want to get it to his level, I think I'd want to learn how to do that. Okay. So something you got for free. All right. All right. Now let's play with this one. This next one is, we will be doing a factorial. And this is going to be a very simple thing. Now, we're not quite done with our check args yet. Okay. But I'm going to give you one more piece of code that we're gonna type in and play with. And then in the lab, you'll be assembling these in different orders to come to the conclusion, okay? So everything we're doing in class, you're gonna kind of redo again, slightly different order, okay? So this one we will just call fact C. And this only has 95 lines of code in it. I'm just joking, not that many. And it's going to be GCC. And in this case, we do want to use the debugger because we're going to play with that a little bit. We'll just call it fact. An interesting problem you will have is you will probably create a program that says, and you'll wonder why it doesn't work. It's because there's a command on Unix called test. So don't use test as a name of a program. Call it junk. Unless there's a command called junk. You type it in first and then see if it does anything. And so fact might be something. I don't think it is. All right. And I don't need that line. Save temps. Okay. So here we go. STD. You know, C is one of those programming languages. I started with C 100 million years ago. And when you go back to a tool like this, been around forever, it's at the core of just about anything in modern computing. You feel like, oh yeah, I remember all this. It's a little dusty, but I kind of remember it. Kind of fun. Visiting an old friend. What's new?
That's how
Now, these terms are actually not very good,
Yes.
but
you would use that command. It's better than-
now that looks funny. That's a very strange looking font. Res is short for result. And you will find programming textbooks, managers telling you use descriptive variable names. And that will really depend on the team you're in. I always used really short variable names when I was writing code because I don't like typing anymore than I have to. And the guy I worked with who mentored me on some of the really geeky stuff I learned how to do, he used even more terse code than I did. So a lot of it has to do who you work with. But some of the most elegant code I've ever worked with was some Perl code that this fellow from Australia he wrote an entire error module. It was called CARP, as in I'm carping on you or whatever. And it would give an error code in a 17-syllable haiku. It was like way cool. And when you looked at the code, it was like reading prose. It was that easy to read. And if you've done anything with Perl, you can't read Perl easily. It's just, but he did all this crazy operator overloading, and he changed the operator plus plus into an actual word that actually worked. It was crazy. But you can really do some, if you write your code where other people can understand it quickly, you are going to be bowed to. Okay. But if you write code that makes it really hard for the next person to follow, they're going to hunt you down and slap you. Okay. You want to write it so the next person can understand it. Okay. Okay. All right. So let's see how this works. And so GCC, make sure I typed it in all right. All right. Oh, I want the -G here. So I get our debugging symbols. And then back. And save temp. Oops. What'd I forget? Semicolon. Nope. Now, if you look at the error that gets generated, notice it tells you what line is on. Okay. And oftentimes it will give you a bunch of errors after that. Well, find the first error, fix it, then move on to the next one. Because generally, if you get it, fix that one, the other ones go away. $720. So what is this doing? Everybody understand what factorials do? Kind of, 5 factorial, blah, 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 6 factorial. So that's what this is doing. So if we wanted to put in something that's a little more descriptive, we could actually put a print F right in here, huh? Print F. And well, let's just cheat. Put that line there. And it shows you. And what I like to do when I do looping like this, let the user know last and loop. I think that'll work. So you can see how it multiplies. Okay. This code would now has a debugger in it. So so now we get to play again. So watch it count and see what it does with the disassemble. Now I had some notes in here that I wanted to bring out if I can remember where I put them. I don't even remember. Mm. Nope. Pardon me while I look for my notes. That's the problem when you work on too many different computers, you forget where you put stuff. Oh, yeah. Hmm. Yeah, I need to mention that. Yeah, there we go. Yeah, there's no. Let me hit Q here. OBJ, LB. Yeah. This is a command I haven't shown you yet. It's called OBJ no. This is kind of, if you take file and do fact, it tells you the very first part of it. But if you want to see more information about it, you can say OBJ dump -D. And it tells you this is the disassemble of what it is. Okay. So it's showing it to you in gas format. This is kind of like debugger, but not. This is actually what's running on the code. And then I can also use a uppercase S. And this intermixes the you can now see my C statements in the middle of my assembler code. Okay. And then if I want to put the line numbers in there, whoops. Yeah, I guess that's like, okay. But D, whoops, there's S. Don't know what S does. Wow, look at all that fun stuff. Look at all that fun stuff. So OBJ dump is another tool we can use. Okay. We did a loop. All right. One more. Yeah, remember all of this code in homework work in progress is going to be together. Now, what we have here is a demo of a header file, one that you create yourself. Okay. This is not copacetic. In other words, this is not normal. What I'm showing you is for demonstration purposes only. Do not use in production. You don't put functions in headers. You just, okay, that's okay. But we are going to do that anyway. Okay. And I'm going to see if I can see this work here. Yeah, I didn't think so. Nuts. Where's the tools I'm used to? And sometimes I really don't like Windows. All right, this is going to be called my header. That's okay. Everybody has their biases, right? Void. And this is going to be add an int A. and an int b. Since a function declaration here, print f. And this is really bad. Putting print statements in headers. That would just, you imagine the debugging. You've got a header calling a header, calling a header, calling a header, calling a header. And oh yeah, that's where the print is. Go shoot them. Added value. A plus B. Here we need a semicolon. Close it, and then we're going to add another one where it's called void multiply. Spell it out, and it's going to be init A, init B. And then basically it's the same thing. Lied. Got the right symbol for multiply? Yep. In most languages, that's correct. Exponentiation is what throws you. Python, exponentiation is double star. The caret is bitwise operator. So it will really mess up your math. Imagine calculating payroll using the wrong operator. You'd only do it once. All right, so we've created two little functions here in the header. And this is simply to, and we'll call it my main.c. And this is and we will compile this very simply, but we'll throw the debugger symbol in there just for fun. And we will add one of them that we know we'll need later is the Oscar 0, no optimizations. And in your chapter that you'll be working through, chapter 10, which is our lab 4, you're learning about the no rewind and some of those other advanced features that you're turning off for the compiler to get your C source code closer to usable assembler so you can actually figure it out. Okay. All right. And then my main C dash O. And we'll call it, I don't know, my main out. Okay. So since we're doing anything with input and output, we need the include stdio dot h. And now the convention is to include yours. Include. This means it's mine. So we will say add. We'll say 400. 600. And then apply. And we'll make this one, I don't know, 50, 20. Good. And then a return. Now, notice we have the add, the function call, but where's the print statement? It's in the header. Okay, so it's going to print. So that's what's going to confuse us a little bit. But we're doing this, whoops, so we can play with this in the debugger. So now we compile it. Wow, not one typo. It compiled. We'll see if I get a runtime error. Ta-da. That's the right answer. Okay. Now, we have finished the code that we need to assemble for our piece parts of our next lab. So let's take a look at what we got here. Let's do clear ls asterisk dot c. So what we'll be doing is our demo N has the scanf in it. So that'd be your first piece that you add to your main C, foo, and foo H. So you have so instead of taking the hard-coded value that's in main, you're going to do a scanf. And then you'll take user input, send it up, bring it back. Next step is you take argc, or the C args. So you put in the name of the file, and then whatever the user wants, passes it back and adds 8 to it. And then the last piece of the puzzle, this is not all one lab, mind you. This is going to be several, at least 2 labs. Maybe I'll break it into 3 labs, is where you create your own header and you add it to the foo.h and do something like the factorial. Okay, so that's the progression we'll be doing in the labs. And I might make them 5, 6, and 7, just so you'll have a lot of things to show off when you're done. And before we're done, I want to show you the printing subsystem. We have what was the command that I used that made it look all pretty? Darn. Yes, I could do that. No, not yet. Not yet. Let's make it simple. So if we type in LP and you send something to the printer, let's say cat C underscore args C vertical bar LP, hit enter. Where did it go? There's no printer running. You have a new directory in your home called uppercase PDF. Guess what you've got? It's a PDF file. How do I look at it? Well, you're on the Jeremy box, right? So let's go up one, go down to this PDF directory somewhere. Double click. There it is. Double click on it. Oh, look. Magic. Print to PDF. Print to text. There's tools that convert PDF files into text. At Foster's, this gave me another big raise, is I took the output of the printer from the mainframe and turned it into a flat file and snarfed it into a database. And people thought I was a genius. Well, everybody had been printing it out because that's what they thought they could only get print outs from the mainframe. So they would print to the print file, which was a spooler, which went to a printer, and they turned around and typed it all in again. There was no reason for that. They just didn't know they could do it. Okay. So it's in a PDF. Do you think this might help your homework assignment?
Yeah.
The whole idea, you can put your code, all kinds of stuff in there and just print it. And if you really are intrigued with this, what I've been known to do is simply create a cron job, which is part of the Linux class. Say once a night, move all my PDFs from this directory into my public HTML directory, and then I can look at them from anywhere on the planet. Okay. That makes sense? Kind of, sort of, not really. All right. But you can print by simply using that command. Let's say homework, work in progress. And you can do it a couple different ways. You can say LP that, or you can put it this way, LP, and then just put in the name of the file. And then it creates another new PDF. I have to refresh it though. So there it is. Which one? I think it's this one. Yeah. So it looks the same. And because it's a PDF, you can upload it and download it. LibreOffice Draw will allow you to edit PDFs somewhat. If they're not too fancy, like the only thing I found, being the only Linux guy on campus, as far as I know, is that the only thing I found that's super difficult under certain circumstances is doing signed PDFs where there's multiple people that have to sign it and using the Acrobat reader. But sometimes the PDF I get is malformed and it won't let you sign it. So I have to print it out, sign it, scan it, send it off. That's my only thing I haven't found that works yet. It will, as we move more and more into the cloud world. Okay. Well, you can come on in. All right. So that is where we are. So what did we do? We did scanf. We did argv, argc. We did factorials. We did a header wrong with a print statement in it. And we put it all into this work in progress. What we'll be doing your homework will be coming as 5, 6, and 7. 5 will take foo dot your main.c, foo.c, foo.h, adding a scanf to it. Document your understanding, play with it in the debugger, add the compile lines for debuggers. Then you do it again for argv argc. And then with argv argc, you'll play it with the debugger. And what I also want you to do with argv argc is put in some guardrails so the user don't mess things up. Okay.
I have a question about that.
Yeah.
All the examples you gave for, malformed arguments, those are all bash things that are expanded in bash first and then passed to C. So you can't check any of those in your C script.
You can.
Oh,
What you do in the case right here, oops, if that's where I'm going with it, is that you have your command line count and you put in an if statement, if not equal to 2 or whatever it is, then you return a 1, but you do a printf. Correct command usage is,
for example, like the asterisk.
mhm,
Your C script never knows that you passed an asterisk because the asterisk becomes.
that's true. That's true.
Same with every other example.
That's true. There are actual libraries that you bring in. You would say on this, when you bring in the argument value, you would have to say, sorry, only integers or only strings, no special characters, and you put up a convoluted test. But there's libraries that allow you to bring that in. There's a word for it, sanitizing your script. So when the data comes in, if it is malformed, it gets ignored. It won't hurt anything. Because oftentimes what happens is that the argv argc becomes an API between 2 running programs. So you have to check your data on the way out, and then you have to check your data on the way in, depending on where it's coming from. But in our case, we're going to do it very simply, and I'll show you that on Thursday, is we'll do an if test if the count is not equal to 2. But as far as setting up an individual string, what I want you to play with is all the special characters and find out what's happening. And then if you have questions about that, ask, because in bash, there's a bunch of them that are special. The question mark, the hash, the star, and then if you have 31 arguments on your line, bash only handles 9. Well, how do you get to the 10 and up? You shift. You have to shift until you're all done. Okay. We'll talk about that more later. Okay. But you are correct. The special characters we'll be throwing at it. How do you check for special characters? You could do a case statement. That's kind of gnarly.
In your C script?
Yeah, you can do it. You can do it anywhere. In the days, yeah, you can do it all in C. So you can think bash is written in C. So anything you do in bash, you can do it in C. Yeah, convoluted, but it's not unheard of. It's another one of these things. It's a library you can import. Like if you use a library called the one I'm familiar with, it's called Seaworthy. And what it did is allowed you to create these wonderful character-based menus for the old school, before we had GUIs and X windows. And it had all that sanitizing stuff built into their library. So it's out there. And that was a long time ago. I'll just leave it at that. So, yeah, I'll show you the if on really simple one. Show it to you. Good question. I'll leave that as an exercise to the reader. Okay. Spend some time on Stack Overflow. You'll find 15, maybe 100 different answers. Because it's a legitimate question. Okay. All right, and then the last piece for 7 is we'll add factorial into our foo.h. So we're building on that very first thing we did. And we keep adding stuff to it, and we're throwing it into debugger, looking at what happens to things as we change it, right? And that's where I will stop at the moment. Okay. And change channels to Linux. Chink. Thank you.
Very good question.
Uh-huh.
I haven't touched BI before. When we're exiting out, you do like WQ, and like sometimes in faster you SKU, is there a difference between the two?
WQ will write and quit.
Okay, thank you, just click.
Q just quits.
That's what I thought, I just wanted to double check.
Yeah, and then if you do escape uppercase ZZ,
Mhm.
that saves an exit.
Okay, I see.
So it's sometimes it's faster, but oftentimes. Oh darn, I don't want to save that file,
Mhm.
you know, because you get so fast at it, you know, so it depends.
Also, my wife for that one assignment, we're saying hi, my name's Jason.
All right, how you doing,
And I'll see
Jason?
you Thursday.
You bet. Hmm.
Yeah, your class after this? Great.
Yeah, it's the Linux class, only on Tuesday though.
Okay.
Yeah. Our count. Check.
I'll see you on Thursday.
All right. Hmm. How you doing,
Good. My name's Fabian, by the way.
Fabian?
Nice
All
to meet
right,
you.
Fabian. All
Yes.
right.
I didn't know we could bribe you with coffee.
That's pretty.
I'm practicing my latte already.
All right.
Yeah, I'm espresso milk. Yeah.
That's pretty cool.
Yeah, I love it.
Yeah.
Yeah, we drink one every day.
Yeah.
Yeah.
Pretty nice.
Yeah.
All
All right.
right.
Take care.
You bet.
You want to hear a funny story? 2 days ago, I had to check my BIOS
We're having fun here. So
and
we're breaking things. Let's see, stop share. And